Hi friends, in this video I'm going to show you how to calculate how to solve some questions on conversion of temperature to scale. Now in this case I'm having 6 questions. I'm going to solve 4 out of it, but the 5 and 6 you'll be the one to solve it and drop your answer in the comment box below. Now as first, let's consider the question I'm having here. Suppose that on a linear scale x, water boils at minus 53.5 degree x and freeze at minus 170 degree x. What is the temperature of 340 degree Kelvin on the S scale? Now, before I solve this question, you need to first watch my explanation on conversion of temperature scales. Once you watch it, you will actually have total knowledge on how to calculate this. This is just a freestyle. You understand? So, as first, we need to consider. You need to know that if you are talking about the upper fixed point and also the lower fixed point, upper fixed point is taken to be the boiling point of the temperature scales, while the lower fixed point is taken to be the freezing point of the temperature scales. Now let's say I'm having scale x, the unknown scale x. I'm having it. Can you see this? Let's say I'm having the unknown scale x, right? And the question is, suppose that on a linear scale x, this is scale x, water boils. Boiling indicates that it is the upper fixed point. Water boils at minus 53.5 degree x. This is the upper fixed point. And freeze at minus 170. Freeze that's minus 170 degree x. What is the temperature of 340 on the S scales? Now, we are having 340 Kelvin. It's just as the scales that the question is talking about is what? Is the Kelvin. Now we can just compare the two scales together. The upper fixed point of what? Of degree Kelvin is taken to be what? To be 373 Kelvin. 373 Kelvin. And the lower fixed point is taken to be what was that? I think that's the 273 actually. Yeah, that's 273 Kelvin. And the thing is that here we have the upper fixed point and also the lower fixed point. We have the upper fixed point and also the lower fixed point. So in this case, how are you going to go about it? We need to compare the fundamental interval, which is the middle part, with it to each other. Now, let's just call this place x and call this side. We are giving this side to be what? To be 340 degree Kelvin. Yeah, because after 273 it should be what? 340. Before what? Before 373. Can you see this down? So in this case, you need to compare the two scales together. So comparing the two scales, we are going to take the fundamental interval. We are going to take its x. We are going to subtract from the what? From the lower fixed point. That will be minus into bracket minus 170 degree x. Can you see it now? So divided by, look at this. So divided by, in this case, I'm sorry, I don't want to use x because I'm actually having what? X in this. Can you see it now? I'm having x. So let me just call this one y, so that it will not confuse us. Now let's just go. So you take this, that was what? Minus 53.5 degree x, right? Subtract from the lower fixed one, that's minus into bracket minus 170 degree x. Then you equate it to this. That in this case, you're having the fundamental interval to be 340 degree Kelvin minus what? Minus the lower fixed one, which is 273 degree Kelvin, divided by what? The upper one, which is what? 373 Kelvin minus the lower one, which is 273 degree Kelvin. Can you see this now? So let's just go ahead and just do simple calculation in this case. So if you look at this, that's what? That's y plus what? Plus 170 degree x, right? Then let me just press everything here on calculator. I'm having minus 53.5 minus into brackets minus 170 degree x here. So let's see the answer. So this is actually 116. That's 116.5x equals to, that's here we're having 340 minus 273. 340 minus 273, that's what? 273, that's 67 in this case. So you have 67 degree Kelvin divided by what? This should give us 100. That's 100 degree what? Kelvin. Right? So let's just cross multiply. So cross multiply, we're having what? We're having 100 degree Kelvin into brackets what? Y plus what? y plus 170 degree x. Can I see this down? Equals, we have what? That will be 116.5x times what? Times 67. Times 67. Now let's just check the answer after this. That's 116.5 multiplied by 67. So that should give us what? 7805.5. So you're having, let me just move to from this to this. That's, we're having what? We're having 100 in the bracket what? Y plus what? 170 degree x equals to what? Equals to 7805 point what? Point 5. Because if you multiply this together, so to give us what? To give us this. Now let's just go ahead and simplify here. We're having what? We're having 100y, right, plus what? Plus 170 00, right, we multiply it together, equals to, that's 7805.5. Then here we have what? 100y equals to what? 7805.5 minus what? Minus 170, that's 17,000, right? So let's just check the differences between that one. That's 7805 7805.5 minus, that's 17,000. That should give us that's minus 100y equals to what? Minus 9194.5. So you can actually divide both sides by 100. Dividing both sides by 100, this cancels this. Then what's the value of y? Y equals to what? That will be, that's minus 91. Actually, let me just go ahead and just do it like this way. That's minus 9194.5 divided by 100. Let's see the answer. So the answer in this case is what? That's minus 91.945. So you can actually approximate it. That's y equals to what? Minus 91.95. Answer is very simple. So let's go ahead and pick the answer in this case. So here we have an option A to be what? Minus 92.1 degree x. Option B to be what? 92. That's this and this, they are what? They are not passed. But if you look at this, our answer is in what? Is in negative. So this one should be what? To be negative, because if you approximate it, it is approximating what? Minus 92.1 degree x. So A is the what? Is the answer. A is the answer. Now let's move to the second case, which is what? Question 2. Don't worry, you understand better. So let's move to question option 2. At what temperature does a thermometer calibrated on Fahrenheit scale read twice? The Fahrenheit scale read twice that of what? Of thermometer calibrated on what? On Celsius scale. This one is actually conversion of what? Of temperature, but the thing is that if you are not careful enough, you won't be able to what? To interpret the question very well, because the question is somehow okay, how can I put it? Let me just say it's somehow, let's say it's not difficult actually, but it's somehow, what the best. Now let's just move to it. At what temperature does a thermometer calibrated on Fahrenheit scale read twice that of a thermometer calibrated on Celsius scale? That means they are talking about two temperature scales here. They are talking about, the first one is what? Is the Fahrenheit, and the second one is what? Is the that's Celsius. So you can actually compare them together. We know that the upper fixed point of it for Celsius is what? Is 100 degrees C, and lower fixed point for Fahrenheit is what? 0 degrees C. Then that of Fahrenheit, the upper is what? Is 212 degree Fahrenheit, while the lower is what? Is 32 degree Fahrenheit. Then what of the fundamental interval? That's what we want to compare. At what temperature does the thermometer calibrated on Fahrenheit, on this Fahrenheit, will read twice that of what? Or calibrated on what? On Celsius. That means if Celsius is what? Is x, then this one is what? Is 2x. We read twice that of what? Of this. If this is x, that means this one will be 2x. That's what the question is what is talking about. Now you can just go ahead and compare it. We take this, we subtract from this. That what? X minus 0 divided by what? 100 minus what? Minus 0. Then equates it to this. That will be 2x minus the lower fixed point, 32 degree Fahrenheit, divided by what? The upper one, which is what? 212 degree Fahrenheit minus what? 32 degree what? Fahrenheit. Can you see this now? So let's just go ahead. X minus 0 will actually give me what? X divided by what? 100 equals to 2x minus that. That is still the same thing as 2x minus what? 32 degree Fahrenheit divided by what? This minus this should give me what? That's 180. That will be 180 degree Fahrenheit. So in this case, I can actually cross multiply. So that if I cross multiply, let's see what I'm going to have. I will have what? This multiply I did, that was what? 180x equals what? 100 into bracket 2x minus what? 32 degree Fahrenheit. So that I'm having 180x equals to, that's this multiply this will give me, that should give me, that's 200x. 200x minus what? 3200. Then let's just collect the like times. Collecting like times, I will have what? I will have, that's actually, this will come here, that's 180x minus what? 200x equals to what? Equals to, should I have x here? That's this most idea is actually 180x. Okay, let's just see, try to pick points where the mistake come from. This multiply, that's x. Okay, 90x equals to, alright, okay, equals to minus 33200, right? So this minus this will give me what? That's minus 20x equals to what? Minus 3200. I don't think there's mistake. So divide by minus 20, divide by what? Minus 20. Okay, so this cancel out this, minus cancel minus, minus will cancel minus, this cancel this. Then we have what? S to be equals to 320 divided by 2. So this here one, this and this should give me what? That's 16. So our x in this case is what? Is 160 degree. So the answer to this is what? Is 160. Now if my Celsius is what? Is 160, then 12 of this is what? Will be 320 degree Fahrenheit. Can you see it? It's very simple. Actually, if I should redraw the temperature scale, that means this will be what? Will be, at least will be the upper fixed point. Now this will be at the boiling point. Okay, so that's just it. Now let's move to the next one. Moving to the next one, let's see, that's question number 3. Question number 3, let's see what's there. A liquid in glass thermometer is graduated in what? In millimeters. So we are having a thermometer that is graduated in what? In millimeters. Okay, so let's see what the question is saying. The upper and the lower fixed points. The upper and the lower fixed points. The upper and the lower fixed points of the thermometer are 230 millimeter and 80 millimeter respectively. What is the temperature in degrees centigrade when the thermometer is what? 95 millimeter. So we are giving what? Yes, we are giving an unknown scale. We are given an unknown scale, and we are asked to compare it with what? With the degree centigrade. Let's just draw out the what? The temperature scales. This for the degree centigrade, which is what? 100. The upper fixed point was 100 degrees C, and the lower fixed point was 0 degrees C. And here the upper fixed point of this, they say the upper and the lower fixed points of the thermometer are what? 230 millimeter. That means the upper fixed point is what? 230 millimeter, and the lower fixed point is what? Is 80 millimeter. They now say that the question now says that what is the temperature in degrees centigrade? So we have to calculate in, that means let's just call this one x. When the thermometer reaches 95 millimeter. So when it reaches 95 millimeter, that means when it reaches 95 millimeter, it should be somewhere here. Can you see now? So you have 95 millimeter. We just need to compare them now. You take this first, that will be 95 millimeter minus what? The second one, which is 80 millimeter. Can you see this? Divided by, you take the top one, 230 millimeter, subtract from the lower one, 80 millimeter, then equals to this x minus 0 divided by 100. Take the upper one, degree C minus what? 0 degree C. Show that let's just do some simplification here. So we have what? We have 95 minus 80. That should give us, that's 15 millimeter divided by 230 minus 80. That should give us 150 millimeter. That's 150 equals to x minus 0 is x divided by 100 minus degree C. That's actually 100 again. So what next? Let's just go ahead and 100 degree C. Let's go ahead and cross multiply. This will cancel this actually. So you have what? 15 divided by 15 divided by 150 in this case equals what? X divided by what? 100 degrees C. Sure that we are cross multiply here. I'll be having that's 1500 degrees C equals to what? 150 what? X. Can you see this now? So I can just go ahead and divide both sides to solve for the value of x. Divide both sides by 150 now. Dividing both sides by 150, this cancel this. I'm having what? X to be equals to this, cancel this out, right? So my x will be equals to, that's 15 in this, that's 1. So you're having, that's 10 degrees Celsius. So my x in this case is scale. A temperature scale has an upper fixed point of 260 millimeter Ag, right? So and a lower fixed point of 50 millimeter Ag, right? So what will be the reading on the scales when the thermometer reaches 125 degree Fahrenheit? So we are given the two scales. Let's just draw it out. A temperature scale has an upper fixed point of 260. That means the upper fixed point is what? 260 millimeter, right? And a lower fixed point of 50 millimeter. The lower fixed point is 50 millimeter. What will be the readings on the scale when the thermometer reaches 125 degree Fahrenheit? That means we have to compare it with what? With degree Fahrenheit, and we know that the upper fixed point of degree Fahrenheit is what? 212 degree Fahrenheit, and also the lower fixed point is what? 32 degree Fahrenheit. So in this case now, we have to compare it. That, let's say this one is what? 125 degree Fahrenheit, because it is larger than 32 and also less than 212. So it should be at middle. Then this will be our what? X if you have to compare it. Then let's go ahead. That what? X minus what? 50 millimeter divided by what? 260 millimeter minus what? 50 millimeter, right? Now then equals to, then let's equate it to this, which is what? That's 125 degree Fahrenheit minus what? 32 degree Fahrenheit divided by what? Divided by 212 degree Fahrenheit minus what? 32 degree Fahrenheit. That's just it. You take this, subtract from this, divided by this, subtract from this minus this, divided by this minus this. That's just it. So let's go ahead and just do some simplification in this case. So in this case, we're having what? X minus what? 50 millimeter divided by what? This minus that should give us 210 millimeter equals to, that's 125 minus 32. 125 minus 32 should give us something like that's 125 minus 32 on this, that's 93. So you're having 93 degree Fahrenheit divided by what? 212 minus 32, that's 180 degree Fahrenheit. So Fahrenheit cancel Fahrenheit here. So you're having x minus what? 50 millimeter divided by what? 2110 millimeter, 210 millimeter equals to 93 divided by 180. Let's just cross multiply and we'll move to the next case. So that we have 180 into brackets x minus 50 millimeter close bracket equals to 210 millimeter multiplied by what? 93. Can you see this now? Yes. Okay, let's go. So here, let's just open bracket. That means 180x minus what? Let's see this. That's 180 multiplied by 50. That's what? That's 9,000. Having 9,000 equals to 21210 multiplied by 93. That's what? That's 19,530. So collecting the lifetimes, we're having what? 180x equals to 19,530 in this case plus 9,000. That means we had it plus 9,000. So we're having 180x equals to 28,000. That's 530. Go ahead and divide both sides by what? 180. Dividing both sides by 180, this cancels this. Then the value of our x is what? That's 28530 divided by 180. That's 158.5. So 158.5 millimeter. That should be the what? The answer. So the tease behind this is that we are going to take the middle fixed point, which is our fundamental interval. You subtract this from the lower interval divided by the upper fixed point divided by the what? Minus the lower fixed point. You equate to the next scale, which is the lower fixed point minus what? The fundamental interval minus the lower fixed point divided by the upper fixed point minus what? Lower fixed point. Then you simplify, and that's all. So question 5 and question 6, make sure you do it to solve them and drop your answer in the comment box below. Don't forget to share this video. My next video will be on temperature scales. That will be resistance scale, because the resistance temperature, because resistance and has a relationship with its temperature. It is proportional direct to its temperature. So there is a relationship between both of them. So I'm going to release